Hey kiddos, I am going to go over solving quadratic equations with you. This is a skill you should have remembered from Algebra 1, but I know a lot of you are rusty and need a refresher. I'm specifically going to solve by factoring using the box method. This is not the only method, there are others out there, but this method I feel like if you learn it the right way, it makes it a little bit simpler for you. So let's try a couple. This example, we are solving for x, and we have this equation 3x squared plus 13x equals 10. First off, I want you to notice that this is not a linear equation, meaning our x terms don't have an exponent of 1 on the x's. We also have an exponent of 2 and an exponent of 1 on our x terms. So this is called a quadratic equation. Now, depending on the way that it's set up, there are several methods to solve these. The best way is to just move everything to one side so that 0 is on the other side. You also want to make sure that the coefficient of your x squared term is positive if you're going to factor. So in order to get 0 on one side, and it doesn't matter which side you choose, to me it looks like it would be easiest to move the 10 to the left so that the 0 is on the right rather than moving two terms to the right and ending up with a negative coefficient in front of my x squared term. So to move 10 to the left, we're going to subtract it from both sides. We'll be left with 3x squared plus 13x minus 10 on the left and 0 on the right, which is what we want. Notice on the left that I did not subtract 10 from either the 3x squared or the 13x. All three of those terms are unlike, therefore we can't combine any of them. The three terms together are called a quadratic trinomial. And I'm going to show you how to factor a quadratic trinomial because at this point we can't just get x by itself. It's not that easy. So here's the method that I'm going to show you. It's called the box method. So the first thing you want to draw is a 2 by 2 box. It kind of looks like those Punnett squares you used in biology. In the upper left box, you're going to put this first term, the 3x squared. And then in the lower right box, you're going to put this last term along with its sign, which is negative 10. So what you're going to do now is you're going to multiply that coefficient of 3 with the negative 10. We'll come back to the 13x in a minute. If I multiply 3 by negative 10, we get negative 30. So what we need to do now are think of factors of negative 30 or numbers that are going to multiply to make negative 30, but we want them to add to make this positive 13. That is the B part of our quadratic trinomial. There's an A part, which is the 3, the B is the 13, and then the C is the negative 10. So if I'm thinking of numbers that are going to multiply to make a negative 30, that means one of the numbers has to be positive and one has to be negative. First I'm going to think of all the factors of 30, and then I'm going to decide, okay, which term would need to be negative in order for them to add to a positive 13. The factors of 30, we've got 1 and 30. I always start with 1. Then I've got 2 and 15. Then I go to 3, which is times 10. 4 doesn't divide into 30 evenly. 5 does, 5 times 6. And then we would go to 6, which would be 6 times 5. Okay, so now I've got to consider, well, one of the numbers has to be negative and one has to be positive. If I want my two numbers to add to make a positive 13, that means the bigger number needed to be positive. So for the 1 and the 30, that means the 1 would be the negative. For the 2 and the 15, that means the 2 would be negative. For the 3 and the 10, the 3 would be negative. And for the 5 and the 6, the 5 would be negative. Now I need to look at each pair. If I add them together, are they going to add up to a positive 13? The pair that's going to work is the negative 2 and the 15. That adds up to a positive 13. So what I'm going to do is I'm going to stick x with both of those numbers, so negative 2x and 15x, and I'm going to put those in the two remaining squares. The place that you put them is not important. So I'm going to put the negative 2x here and the positive 15x here. So the hard part is over. Now you're factoring from each column and each row of your box. So we're going to be factoring 4 times. And I'm going to choose another color so it's a little bit easier to see what it is that we're doing. Okay, so if I want to factor from the first column, I'm going to look at the 3x squared and the negative 2x. And I'm trying to think of some factor that they both have in common. 3 and negative 2, if I'm looking at those coefficients, the only number I can divide into both of those evenly is 1. So 1 would be the factor of the coefficients, the greatest factor. If I look at the variables, I've got an x squared and an x. X squared, remember, means x times x. So the x squared is kind of like 2 x's, and then the x by itself is 1x. Both terms have at least 1x. So I can pull out an x, I'm going to place it on top. The coefficient of that x is the 1 that was the common factor of 3 and negative 2, but if you remember, if my coefficient is 1, I don't actually have to write it. So that's the common factor of that first column. If I look at the second column, I've got 15x and negative 10. If I look at the number portions, 15 and negative 10, I'm going to think of a factor of both of those numbers that's the largest. And what I'm thinking of is 5, so I'm going to write that down. Now if I look at the variables, the negative 10 doesn't have an x. So I couldn't pull I couldn't pull an x from the negative 10. Now if the negative 10 also had an x, I could pull an x from both of them. But all we have right now is we've got an x and a 5. And keep in mind that 5 is positive. Now if this 15x in the upper right corner, if that was negative, then I would make sure that I would pull out a negative 5 there, but it's not. The two boxes that are going to determine if you're pulling out a negative or a positive, if the upper right box is negative, then you're going to pull out a negative from that column. If the lower left box is negative, like it is here, then when we pull out from that row, that bottom row, we will have to pull out a negative. So I'm going to put a negative there to remind me I've got to pull out a negative. But let's go ahead and look at that top row. I've got 3x squared and 15x. If I look at the numbers, 3 and 15, the greatest common factor of both of them is 3, so I'm going to pull that out. And then if I look at the variables, they both have at least 1x, so I can pull an x out. I wouldn't be able to pull out x squared because the 15x only has 1x. I couldn't pull 2 from it. If I look at the lower row, the negative 2x and the negative 10, if I look at the number parts, negative 2 and negative 10, the greatest common factor is 2. I've already decided that it has to be a negative 2. Because the negative 10 doesn't have an x, I can't also pull an x from it. So this is what I have. So how does this translate to finishing solving this equation? The 2 terms that we pulled out from our columns, which are on top of my box, are right here. I'm going to put parentheses around them. This is one of the binomials that my 3x squared plus 13x minus 10 trinomial would factor into. Because the 5 is positive, I'm just going to put a plus between them. The terms on the left are going to make up another binomial. And because the 2 is negative, that means there's going to be a minus sign between them. So if I come back over to my equation, I can rewrite those 2 binomials underneath like this. So all we did was we took the quadratic trinomial and we factored it into 2 binomials, or two terms. It doesn't matter which binomial I put first. I could put the 3x minus 2 before the x plus 5. That's not important. If you want to check your work to see if you did it right, you can always come back over to the side and double distribute. Some of your teachers, maybe in junior high, called it FOIL. You take one term from each binomial and make sure to multiply it by both terms in the other parentheses. So for example, I would take the x and multiply it by the 3x and the negative 2, and then I would take the 5, multiply it by the 3x and the negative 2. And when I do that, I should get 4 terms. So let's just see what happens just to make sure that we factored correctly. So x times 3x is going to be 3x squared. X times negative 2 is going to be negative 2x. Then if I go to the 5 times 3x is positive 15x. and 5 times negative 2 is negative 10. And usually when we double distribute, or many times, the two middle terms, in this case the negative 2x and the 15x, are going to be like terms, and you would be able to combine those. The 3x squared is not like the other terms because it's the only one that has the exponent of 2, but the negative 2x and 15x can combine to make a positive, 13x, and then we have the minus 10 at the end. And if you notice, this trinomial is the exact trinomial over here in green that we started with. So this part over here is just a way to kind of check your work if you're not sure if you factored correctly. But if you follow the box method and practice it a lot, you should be factoring correctly. It kind of takes a lot of the guesswork out. Let's go back to our equation. What we have now is we have a binomial times another binomial, and that equals 0. If you think of two things that multiply together to make 0, one of those things has to be 0. So what we have to do is we have to consider that both of these could equal 0. The x plus 5 could equal 0, so you just set it equal to 0. And the 3x minus 2 can also equal 0. Now you've got two little mini equations, and you just have to solve them. So on the left equation, I'm going to subtract 5 from both sides to get x by itself. So x equals negative 5. There's one solution. And then on the right side, I'm just going to solve for x. So I'm going to add 2 to both sides. Then I get 3x equals 2. Then I'm going to divide both sides by 3. And I'm going to get x equals 2/3. So there are two solutions to this equation. A lot of times when you have a quadratic, you'll either get two solutions, one solution, or no solution. But many times you'll get two solutions. Okay, here is another quadratic equation that we need to solve for x. I know it's quadratic because I see that exponent of 2 on my x term, on one of my x terms. So because we have an x squared term and an x term, we want to set everything equal to 0, and hopefully we can factor. If I'm looking at this and I want to make sure that my coefficient of my x squared term stays positive, that means I want to leave that 6x squared on the right, so I want to move everything over to the right. I'm going to add the 19, or I'm going to add 19x to both sides. So that's going to give me 0 on the left. I've got 6x squared. Now I want to put the 19x first. You always want to put them in descending order of exponent. And then I'm going to put the 8 last. These three terms, the 6x squared, the 19x, and the 8, are unlike terms. This is a quadratic trinomial. Now I need to factor it into my two binomials. So I'm going to go off to the side, and we're going to try our box again. In the upper left box, I'm going to put my first term, the 6x squared. In my lower right box, I'm going to put the 8, my last term. Then I'm going to multiply the number parts of both of those boxes. 6 times 8 is 48. And then I'm going to consider all the factors of 48. Now remember, what we're trying to do is we're trying to look for the factors of 48 that are going to add to make this b, the coefficient of the x term, that middle term, 19. So I always start with 1. So 1 times 48. Then I'll go to 2. 2 times 24. Then I'll go to 3. 3 times 16. Then I'll go to 4. 4 times 12. 5 doesn't work. 6 is a factor. 6 times 8. 7's not a factor. 8 would be next. And it would just repeat the pairs that I've already have. Because my 48 is positive, that means my factors can either both be positive or both be negative, because negative times a negative is a positive, but I want them to add to make a positive 19. If I add two negative numbers, I'll never get a positive number, so I need them to both stay positive. So I don't have to worry about the signs for this one. The two numbers, the two factors that are going to add to 19 are the 3 and the 16. So I'm going to stick an X with both of them and place them in the two remaining boxes. Remember, it doesn't matter which box you place them in. So the hard part's over. Now I'm just going to pull out the common factor for each column and each row. For the first column, if I look at the numbers, the greatest common factor would be 3. They can both be divisible by 3. The greatest common factor of the x parts is x. Second column, the number part, the greatest common factor is 8. And because they both don't have an x, I can't pull an x from both of them. Now because that 8 is positive, I'm just going to put a plus sign between those, and this is going to be one of my binomials. Now I'm going to look at each row and pull out the common factor. The top row, if I look at the 6 and the 16, the greatest number, or the greatest factor I can pull out from both of those is a 2. They both have at least one x, so I can pull out one x from both terms. In the bottom row, the greatest common factor of 3 and 8 is just going to be 1. They don't have any other factors in common, so I can pull out a 1. And because the 8 doesn't have an x also, I can't pull out any x's. So in this case, I'm just going to pull out a 1. And I need to remember that because that 1's positive, that means there's going to be a plus between my 2x and my 1 when I make my second binomial. So those are my two binomials, 3x plus 8 and 2x plus 1. It doesn't matter which one I put which in my parentheses. 3x plus 8, 2x plus 1. Feel free to go off to the side and double distribute just to make sure that we did it correctly, but I'm telling you we did. So that's good. The next step is to take each of the binomials and set them each equal to 0. 3x plus 8 equals 0, and 2x plus 1 equals 0. And this will give us hopefully the two solutions. Sometimes you'll split it off into two mini equations and you'll actually get the same number for both. And that's very rare, but it will happen. So 3x plus 8 equals 0. I'm going to subtract 8 from both sides first. 3x equals negative 8. I'm going to divide both sides by 3. So x equals negative 8/3. And there's nothing wrong with leaving your answer as a fraction. You may convert it to a decimal. It's going to be a repeating decimal. Fractions are fine. And even though it's improper, that is much better. We don't use mixed numbers, so just keep your fractions improper. The next equation, I'm going to subtract 1 from both sides. So we get 2x equals negative 1. Then we'll divide both sides by 2. So x equals negative 1/2. And this is my other solution. These are my two solutions to this quadratic equation. Okay, this is the last example. Again, this is a quadratic equation. I've got an x squared term and an x term, so I want to set everything equal to 0, but we need to be smart about which side we put the 0 on. The coefficient of my x squared term is a negative currently, so in order to make it positive, I'm going to want to move it to the other side, which means I want to move all my terms to the right. So the first thing I'm going to do is I'm going to add 20x squared to both sides. So I'm going to get negative 2 equals, and I want to put my terms in descending order of exponents. So I'm going to put the positive 20x squared term first, and then the minus 14x. Now I need to move my negative 2 over, so I'm going to add it to both sides. It's going to end up being the last term on the right. I've got 0 on the left, 20x squared minus 14x plus 2 on the right. So what I have again is a quadratic trinomial, and this one has a little bit something extra that we didn't do with the other ones. Now you always want to check for this, and I didn't mention it on the other ones. But if you look at all three terms, they all have a factor in common, and that factor is 2. So I could factor right now using these numbers, but if I could pull out a factor that they all have in common from the beginning, it's going to make my numbers smaller, which means it's going to be easier to work with. So what I can do is I can pull a factor of 2 out of all three terms. And basically you're just thinking, okay, what did I multiply the 2 by to get that term? So to multiply I multiplied the 2 by a 10x squared to get the 20x. So everything that's left I'm going to keep in parentheses. So I'm going to have a 10x squared. It's kind of like you're dividing each term by 2. Minus 7x plus 1. And if you want to check what we did, it's basically the opposite of distributing. Factoring is the opposite of simplifying. So you're kind of expanding things, making things less combined. If I wanted to check this, I could distribute the 2 back in. 2 times 10x squared is going to give me that 20x squared. 2 times negative 7x gives me the negative 14x, and 2 times 1 gives me 2. So we did it correctly. So what we're going to do now is we're going to take this part, that quadratic trinomial, and we're just going to factor that part into the 2 binomials. We're going to leave that 2 out in front for now. So let's go over here. We're going to try the box one more time. Upper left corner goes our first term, 10x squared. Lower right corner is our last term, that's our positive 1. We're going to multiply the 2 number parts together. 10 times 1 is 10. And then we're going to list the factors of 10. Now we want those factors to add up to a negative 7. Right here, this is our B term. In order for 2 numbers to multiply to make a positive number, but to add to make a negative number, both numbers are going to have to be negative. So when I list my factors of 10, I want to list only negative factors. I'm going to start with negative 1. Negative 1 times negative 10 gives me positive 10. Then I can go to negative 2. Negative 2 times negative 5 gives me positive 10. 3 is not a factor, 4 is not a factor, 5 I already used, so those are my 2 pairs of factors. The pair that adds to a negative 7 is the negative 2 and the negative 5. So we're going to stick an x with both of these and place them in the 2 remaining boxes. Negative 2x, negative 5x. Now remember what I said, and I'm going to switch colors again. I said if either this box or this box was a negative, I've got to pull a negative out. If the upper right box is negative, I'm going to pull a negative out from that last column. If the lower left box is negative, I'm going to pull a negative out from that lower row. So those 2 numbers right there are going to be negative. Let's look at our first column, 10x squared minus 2x. For the number parts, 10 and negative 2 both have a factor of 2 in common. That's the greatest. They both have at least one x, so I'm going to pull out an x. If I look at my second column, 5 and 1, the only factor they have in common is 1. And since the 1 doesn't have an x, I can't pull out an x. So the most I could pull out is a 1. So basically, if your 2 terms have no factors in common other than 1, you would just put 1. But I got to remember that this is a negative 1 because that upper right box is negative. If I look at the top row, 10x squared and negative 5x, for the number portions, the greatest common factor of 10 and negative 5 is going to be a 5. And since they both have at least one x, I can pull one x out from both of them. For the bottom row, negative 2 and 1, their greatest common factor is a 1. And since the 1 doesn't have an x, I can't pull an x out. So again, just like the last column, the last row's greatest common factor is just going to be a 1. And in this case, it has to be negative because that lower left box is negative. So these are my 2 binomials. Remember, it doesn't matter which order we put the binomials when we go back to our equation. So we've got 2x minus 1 and 5x minus 1. Now, this time we've got 3 things that are going to multiply to make 0. So that means either of those 3 things can equal 0. So the 2 could equal 0, but oh wait, it can't. So that's not going to give me any kind of a solution. So we can kind of just ignore that. I'm going to really focus on these 2 binomials. I'm going to set them each equal to 0. So 2x minus 1 equals 0, and 5x minus 1 equals 0. For the 2x minus 1, we're going to add 1 to both sides. Oops. 2x equals 1. Then we're going to divide both sides by 2. And I can leave it just as a fraction. So one solution is that x equals 1/2. Let's go to the second equation. I'm going to add 1 to both sides to get rid of that -1. 5x equals 1. Then we're going to divide both sides by 5. And x can also equal positive 1/5. So those are a couple examples solving quadratic equations. Remember, when you have an x squared term and an x term, you've got to move everything to one side and get 0 on the other side. Take what's on the other side of the 0. If it's a trinomial, then we're going to factor it into two binomials. You may want to consider looking at the coefficients of the three terms and that last constant to see if there is a common factor like this 2 that you could pull out. So that could help lower your numbers and make them a little easier to work with. Now, when I was doing this problem to get ready for this video, I actually didn't pull a 2 out in the beginning. And what I ended up with for my two binomials, and this is just like a side note, rather than this right here, I'm going to show you what I ended up getting. I got 4x minus 2 and 5x minus 1. Now the 5x minus 1 is the same, but the 4x minus 2, notice you could pull a 2 out of both of those terms out in front, which is going to make this 4 a 2 and this 2 a 1, and that's how you're going to get what I had over here. So you could do that at the end. Now let's say I didn't realize that the 4 and the 2, let me back it up a little bit, that I didn't realize that the 4 and the 2 had a common factor. And so this is what my equation looked like. And so when I did my mini equations, the one over on the right is still going to give me 1/5, but let's look at the one on the left. So if I had 4x minus 2 equals 0, let me show you what happens. Let me erase something really quick. I'm going to erase this just for a second. Okay. So what's going to happen, I'm going to add 2 to both sides. And I'm going to get 4x equals 2. And then when I divide by 4, I get x equals 2/4. But 2/4 is going to simplify to 1/2. So notice I still get the exact same solution. So if you don't see the 2 or the common factor that they all have to pull out, it's not the end of the world. A lot of times you'll still get the right answer. All right, if you have any questions over this, just bring them to class. Love you guys.